Number one on the study guide, the number of boys in every classroom of a school varies directly as the number of girls. So if we look, number of boys varies directly as the number of girls in every classroom of a school, just extra information. As soon as I see the word varies, I'm looking for directly or inversely. Directly just means the number of boys equals K times the number of girls. So boys varies as B equals K directly times whatever the next thing is, in this case girls. So the next sentence or phrase should give us the number of boys and girls in one classroom. So in one room there are 12 boys and 4 girls. So that establishes specific values for boys and girls, which we substitute in for those two variables, leaving K the only variable that we don't know. Divide both sides by 4, that leaves me with K is equal to 3. Once I know the number that K is, that just tells me the constant of variation, so I'm going to substitute that back in here. So B is equal to 3G is what we get. And then we go to solve the problem. It says, in another room there are 7 girls, how many boys are there? So number of boys is unknown, there are 7 girls, 3 times 7 is 21 boys. Number 2, also a varies problem. You see the word varies, so it's that kind of a problem. Number of RPM varies inversely as the number of teeth. RPM varies inversely as teeth. So RPM equals K. So RPM varies, R equals K. Inversely means divided by, and then the next thing, which is teeth. And then we go on to look at the information given here. It says 50 teeth resulted in 80 RPM. So they're telling us 50 teeth, 80 RPM. Put 80 over 1 to create a proportion. 1K, that product, equals 80 times 50, which is going to be 4,000. And again, K is a constant variation. So once you know what K equals, it stays the same throughout the problem. We transform our original variation statement, R equals K over T, to R equals 4,000 over T. And then finally, what would be the RPM if the gear had 25 teeth? So they're telling us how many teeth there are, 25. They're asking us for what the RPM is. So R is going to equal 4,000 over 25. And if we divide that out, we're going to get 160 RPM. So example 1, problem 1 on the test is going to be a direct variation, problem 2 inverse variation. Just be familiar with the technique for both of those. Example 3, the volume of a quantity of ideal gas was held constant. So as soon as I see the words ideal gas, I'm expecting that P1 V1 over T1 equals P2 V2 over T2 formula to happen. And the fact that volume is held constant tells me that volume can be thrown out of the formula. So P1 over T1 equals P2 over T2. And the one requirement of this formula is that temperatures are in degrees Kelvin, which you can see degrees Kelvin is what we're given for temperatures, so we're in good shape there. So I'm going to put P1 equals something, T1 equals something, P2 equals something, and T2 equals something. And I start reading the problem to investigate this information. The initial pressure and temperature were 300 newtons per square meter and 400 kelvins. And they don't specify this is the pressure, that's the temperature, but the fact that they're in that order here and they give them that order, also knowing that kelvins is a temperature unit, newtons per square meter is a pressure unit, you should know those. What would be the pressure, question mark, newtons per meter squared. Alright, if the temperature were increased to 800 kelvins, so increased to this, so new temperature is 800 kelvins. So at this point we simply need to figure out what P2 is. There's our relationship between the numbers, so 300 over 400, that's P1 and T1, is going to equal final pressure we don't know yet over T2, which is 800. And you can reduce 3/4 instead of 300 400s. Cross multiply 4 p sub 2 is equal to 2,400. Divide both sides by 4, we get p sub 2 is equal to 600. And again, pressure unit is newtons per meter squared, 600 newtons per meter squared. Make sure you put the proper units on those. Number 4, convert to polar form. Okay, like we discussed just this week in, I think lesson 63 is where it happened. Converting to polar form is a matter of 3 steps. First step of the process, negatives don't matter. R is going to equal the square root of first thing squared plus second thing squared. I'm going to get my calculator out. And I'm just going to type that in exactly. Square root, parentheses, 7 squared plus 5 squared. Again, plus 5 squared. Don't put negative 5 squared in there. Just everything's positive. We're squaring things, they become positives. So just go ahead and assume that and make life easier on yourself. So we get 8.60. Okay, step 2, we want to find alpha. Alpha is always the inverse tangent of the absolute value. Absolute value makes things positive, so again, ignore the minus sign in the step. The second over the first. It's always the second over the first. It's never ever anything other than that. So second over the first. Second tan, so we get tan negative 1, second divided by first, and parentheses equals, gives me an angle of 35.54 degrees. Finally, step 3, that's where the minus sign matters. We're trying to convert to polar form. We need to determine what quadrant we're in. Their choices are first, second, third, and fourth. 7i minus 5j takes me to the right and down, so my vector lives in the fourth quadrant. The rule for the fourth quadrant for theta is equal to 360 minus alpha. So if we subtract that out, we're going to get theta is equal to 324.46. So my magnitude R, 8.60, my angle theta, 324.46, gets me my polar form answer. I'm expecting your answer to look like that. And again, the technique is right there. The formula sheet contains the technique. It contains all the rules for how to find theta based on quadrant. It's up to you to apply everything properly. Number 5, solving a system of equations here. I've got fractions and decimals. I multiply everything by 10 in the fraction problem to get rid of the fractions. Common denominator is 10. 10 divided by 5 is 2 times 2x is 4x. 10 divided by 2 is 5 times 3y is plus 15y. 10 times 8 is 80. In the decimal problem, 2 decimal places, 1, 1. So if I make this 0.30y and 1.30, now everything has 2 decimal places. Multiply by 100, all the decimals move to the right 2 spaces. So 2x plus 30y is equal to 130. So you transform it from what it was into a simpler problem. Now I'm noticing this decimal one, that everything happens to divide by 2. No guarantees that happens on the test, but always look for that possibility when you're doing a system of equations, that everything divides by the same number. And by doing that, notice the 15y and the 15y are the same, so I just change the signs in this bottom equation. So it starts off as x plus 15y equals 65. I'm going to transform it to negative x minus 15y equals negative 65. 4x minus x makes 3x. 15y minus 15y cancels. 80 minus 65 is 15. Just like that, divided by 3, we get x equals 5. Once we know that x equals 5, I go back to either equation. I'm going to go back to this one. 4 times x plus 15 times y is equal to 80. That's 20 plus 15y is equal to 80. Move the 20 over and subtract. We're going to get 15y is equal to 60. Divide by 15, we get y is equal to 4. Once we know both x and y, x first, y second, in order of pair. So expect a similar structure on the test. Expect the answer to come out to nice integer answers like that. I'm not going to make it come out fractional. So if you're getting integers, you're probably doing it right. Examples 6 and 7 are both solved by completing the squares. And the first technique, the first thing we want to do is we want 1x squared. We want my x's the same side. I want my constants the other. So I'm going to move the 6 over there. I'm going to move the 13x over here. And I'm going to divide everything by 6 to make that happen. So divide by 6, I'm going to get 1x squared. Divide by 6 and move, I'm going to get negative 13 over 6x. Leaving a gap equals, and then 6 moves over as a negative 6. Divided by 6 is negative 1. You know, if you're not as comfortable doing all that at once, first of all, move the 13x over, divide everything by 6, and then move everything around. But x squared, something x, gap equals constant is what our first goal is for completing the square. Step 2 is to actually complete the square. We're going to add the same amount to both sides. I'm leaving myself space for making a common denominator there. Taking half of a fraction is either halving the top, which is not possible because it's odd, or doubling the bottom. I'm going to do double the bottom. So 13/12 is half of 13/6. I got to do 13/12 squared. So I'm going to have to do 13/12 squared over here. On this side, I write it as a fraction squared. On this side, I actually square the fraction. And that creates for me this denominator 144. So I'm going to create that common denominator 144 in those two objects. So what's left on the left-hand side now is this trinomial, which factors very easily to a binomial squared. The middle object's sign is the sign in here. And we just take the square roots of these two perfect squares, which just requires me to take the squares off of each object. Over on this side, I add the two fractions, which have already created the common denominator. 169 minus 144 equals 25 over the common denominator 144. Okay, once I get to the binomial squared equals the number, now I'm going to square root both sides. So x minus 13/12 stays on the left. The square root of 25, 144 says 5/12. Just so happens 25 has a perfect square root, so does 144. The bottom number always has a perfect square root. The top number doesn't always. But do make sure there's a plus or minus in front of it. When the top does have a perfect square root, you get this nice rational number here, 5/12. I expect you to get nice rational answers when you finish this up. So last couple steps here, I'm going to move the 13/12 over to the right. And it's negative 13/12, so when it slides to the right, it becomes positive 13/12 in front of the plus minus sign, and then plus or minus 5/12. So again, usually at this point we're done, right? We have 13 plus or minus the square root of some number over 12. But since that 25 144s came out to a nice pretty number like that, I would expect you to go one extra step to actually add the two fractions and subtract the two fractions. So 13 plus 5 is 18 over 12. 13 minus 5 is 8 over 12. Both those numbers reduce, this by 6 down to 3/2, and this by 4 down to 2/3. So I'd expect that. Expect the one on the test for that one to be the same type of problem, where this will have a nice exact square root, like so, so you should be able to break it down to here. If you stop here, I'm going to take off half credit. Or let's say you left at square root of 25, I'll take a half credit off. So if you have the right answer to this point, it just hasn't been simplified down to the best answer, you'll lose half credit on that. Number 7, solve by completing the square. Same idea. I want the 9x over on the left-hand side, the 2's already on the right-hand side. This is 5x squared. I've got to divide everything by 5 as I'm doing this. So divide by 5, I'm going to get 1x squared. Divide by 5 and move over becomes positive 9 over 5x. Leaving a gap for completing the square equals 2/5. Okay. Divide by 5, divide by 5, divide by 5. Once again, the complete the square step is a matter of taking half of this fraction. Again, either half the top, can't do it because it's odd, or double the bottom. 9/10 is half of 9/5. We're going to square it. So I'm going to add 81 100ths to this common denominator of 100. So I got to multiply top and bottom by 20 to make that happen. So I get 40 over 100. So once again, I've got my perfect square trinomial over here. I've got my fractions to add over here with common denominator already created. Once again, when I factor, the sign is whatever the middle term sign is. Square roots of the perfect squares just reduce, or just take the squares off of the objects. Over on this side, 40 plus 81 makes 121 100ths. 121/100ths. Once again, I got a perfect square equal to a number, so I'm going to square root both sides. This side becomes x plus 9/10. This side becomes plus or minus 11/10. Once again, perfect square, so I would expect on the test this one also will come out to exact squares, so you should have an exact square root. So last step, to get x, I'm going to move the 9/10 over. It's positive 9/10 moves across to the negative 9/10 plus or minus 11/10. And again, since I've got exact square root here, I'm going to expect you to go the extra step of actually adding and subtracting those two fractions. Negative 9 plus 11 makes 2 over the common denominator of 10. Negative 9 minus 11 is negative 20 over the common denominator of 10. 2/10 reduces to 1/5. Negative 20/10, negative 2. Again, full credit, half credit. Make sure you go all the way to the end on these problems. I would expect both of them to come out like this on the test. Number 8. Simplify 5i cubed minus the square root of negative 9 plus 2 times the square root of negative 25 minus 6 plus 2i squared. The first priority on these problems, as I mentioned in class, is radicals with negatives in them, or even radicals in general. Deal with those before you start dealing with the i's to power. So 5i cubed is perfectly fine the way it is for right now. We'll worry about that in a minute. This minus sign is still minus. This negative in the radical creates a positive I outside the radical. The square root of 9 stays a square root. This plus 2 stays plus 2. This negative inside the radical creates a positive I outside the radical. The 25 stays in. And then minus 6 plus 2i squared. So if we focus just on the radical stuff, all this, compare that to what we had up here. Everything in blue was not messed with. So 5i cubed stayed the same. Minus 6 plus 2i squared stayed the same. What I've got circled in red here, the minuses came outside the radicals as i's. Everything else stayed as is. The other thing about radicals is they can't evaluate sometimes. The square root of 9 is equal to 3. The square root of 25 is equal to 5. 3 times this, 5 times this. So make sure that we're going to multiply those to get our result. So I'm going to get 5i cubed. I'm going to get minus 3i. I'm going to get plus 10i. I'm going to get minus 6 plus 2i squared. Get yourself down to this level every time before you start worrying about the i's to powers. The pattern is and always will be I to the first is I squared is negative 1, I cubed is negative I to the fourth is positive 1, and then I to the fifth starts back over. 5 times I cubed becomes 5 times the replacement of I cubed, which is negative I. Minus 3i to the first is perfectly fine. Plus 10i to the first is perfectly fine. Minus 6 is perfectly fine. 2i squared is going to become 2 times negative 1. Again, these are being multiplied, those are being multiplied. Anytime you substitute in. So i's to powers bigger than 1 need to be fixed. I's to the first power and real numbers are perfectly fine in that step. Then if I simplify, I get negative 5i. And product multiplied, opposite sign is going to negative. Minus 3i is still the same, plus 10i is still the same, minus 6 is still the same, plus 2 times negative 1 is minus 2. Real sum, negative 8, signs match, so we add imaginary sum. Negative 8 plus 10 is going to be plus 2i. So negative 8 plus 2i is my final answer. Real first, imaginary second when you write final answers on these problems. Number 9, convert 75 centimeters per second to miles per hour. So I'm trying to convert centimeters to miles, and I'm trying to convert seconds to hours. And it doesn't matter which one you do first. Just know that centimeter to mile conversion has no bearing on the second to hour conversion and vice versa. So let's start with the centimeters to miles. I know that 2.54 centimeters is equal to 1 inch. I know that 12 inches is equal to 1 foot. And I know that 5,280 feet equals 1 mile. I can go that route. I could have gone from centimeters to meters to kilometers to miles also. There's a way to go that route. But this route works. Centimeter on top, centimeter on bottom, cancel. Inch on top, inch on bottom, cancel. Foot on top, foot on bottom, cancel. Miles left on top, which is what we want on top. Miles on top per hour. Next, I want to go from seconds into hours. I know that 60 seconds is equal to 1 minute. Notice I'm locating seconds in the numerator to deal with the second in the denominator. Those seconds cancel. Now I've got minutes in the denominator, so I know that 60 minutes is equal to 1 hour. Minutes on top, minutes on bottom cancel, leaving hours on bottom. The leftover units, miles on top per hour on bottom. And numerically, I've got a 75 and a 60 and 60 on top, a 2.54, 12, and 52 on the bottom. So I'm going to type in 75 divided by 2.54 divided by 12 divided by 5280 times 60 times 60. Top number divided by bottom, divided by bottom, divided by bottom, times top, comes out to 1.68 miles per hour. A couple decimal places for a final answer is always fine. Number 10. Simplify the cube root of 32 times the fourth root of 2. The bar here extends all the way over the second radical, so my advice has always been to deal with the inside object first, leaving this 3 outside all the way through until we're done. So I'm going to keep the cube root in there until I deal with what the inside should be down to a single object. So 32 is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So 32 is 2 to the 5th power. And this is the fourth root of 2 to the first, that's 2 to the 1/4 power. Okay? So you want both of these numbers written as the same number raised to a power. Usually it's going to be whatever this number is. If that had been, let's say, an 8, 2 to the 3rd power, 2 to the 5th power, so 2 to the 3/4, something like that. So you might have to reduce both of them down to something smaller. But you're looking for them to be the same number raised to some power. That gets me down to the cube root of, and we multiply the same base by rewriting the base, not changing that. So 2 times 2 makes 2. We're going to multiply by adding the powers. 5 being added to 1/4. 5 is the same as 20/4, so 21/4 is what we get out of that. And once you get the inside down to a single object, some number raised to some fractional power, we deal with this index by multiplying the index times the denominator of that. So I'm going to get 2 to the 21 over, and then 3 times 4 makes 12. And that's the final answer. That's correct. The one last thing I notice on this one that hopefully you guys would notice also is that 21/12 reduces by 3 down to 7/4. That'd be the best answer. I'd give you full credit for that. It's not wrong, but do look to reduce fractions when possible. Number 11, similar looking problem to the last one. A couple differences. Number 1, it's got letters instead of numbers. Number 2, this radical doesn't extend over the other radical. So it's this radical being multiplied by that radical. And I will have this raised dot, so there's no, I guess, ambiguity about that. So that 4th root goes to those, the 5th root goes to those, and the powers inside there are 4 and 2, and the powers inside here are 3 and 1. So the first step is to rewrite each of these in fractional power form. So this one here, m is a base, we take the inside divided by the root. P is a base, we take the inside divided by the root. Second one, we're multiplying. We got m as a base, inside divided by the root. And for p, base, inside divided by the root. So in each case you just take the inside power divided by the root to create the fractional powers. And then we're going to multiply common bases. So m gets to multiply by m by adding the 2 powers. So we're going to add 4/5 and 3/4. Common denominator of those fractions is 20. So I'm going to go ahead and call this 16 over 20, multiplying top and bottom by 4. I'm going to go ahead and call that 15 over 20, multiplying top and bottom by 5. We're going to multiply the p's together the same way by adding the powers. The powers are 2/5 and 1/4. Common denominator again of 20. Multiply top and bottom by 4, we get 8/20. Multiply top and bottom of that by 5, we get 5/20. So my final result, 16 and 15 make 31 over the common denominator of 20. For p, 8 and 5 make 13 over the common denominator of 20. And that's what we're looking for a final answer. Both these letters in the problem raised to some fractional power in simplest form. Number 12. This is one that I'm going to recommend that you do it like this on the test too. It's going to look just like this. What I want you to notice about this right off the bat is 25 has an exact square root. Right? So a lot of us get gung-ho about doing this technique that we learned on how to do this without first of all looking at some kind of occurrence like that. If I break this apart into 6 times the square root of 7 over the square root of 25, leave a gap, minus 4 times the square root of 25 over the square root of 7, leave a gap, plus leave a gap, 4 times the square root of 2 times 2 times 7. Okay, just our basic technique for doing this. And I go ahead and multiply top amount of this by the square root of 25, top amount of this by the square root of 7, and start taking my 2's out. So you just kind of get into a groove on these problems and don't think while you're doing these problems. Then you might miss out on some easy stuff. First off, the reason I'd multiply top and bottom of this by the square root of 25 is I don't want square roots in the bottom. Square root of 25 is 5, I don't have a square root in the bottom. So that's already fixed. Okay, so when you get exact square roots, which happens quite often in these problems, it might even get something like the square root of 8. And that's 2 times the square root of 2. Square root of 2 is simpler than the square root of 8. So anytime you can make those square roots simpler or smaller, it's worth doing. This is accurate, but this is better. So again, if you get that perfect square root in there, take it. The square root of 25 is 5, being multiplied by 4. Take it. Alright, so if I do that, I end up with 6 times the square root of 7 over 5. I don't have to fix that, it's already in good shape. I'm not even going to leave a gap because I don't have to fix it. Here, I got 20 over the square root of 7. This I do have to fix. I got a square root in the bottom. So I'm going to multiply by the square root of 7 over the square root of 7. That'll fix that. And then here, I can go ahead and take my 2's out. So I'm going to get plus 8 times the square root of 7. So what we end up with is 6 times the square root of 7 over 5 minus 20 times the square root of 7 over 7 plus 8 times the square root of 7 over 1 if you want to have a common denominator, or just a denominator on that. Everything's square root of 7. So again, if I multiply top and bottom of the square root of 25, all of a sudden I got the square root of 175 here, and that doesn't match the square root of 7. So again, expect it to have a perfect square on the test, and expect to handle it in this manner. My overall goal before I start adding and subtracting is everything is something over a whole number, and these radicals should all match. So if they don't match, know that the same thing I did here would happen on the bigger numbers over here, but again, you're just making things way too complicated if you go that route. What's left to do then is to add the fractions by getting a common denominator. The common denominator in this case is 10. This fraction multiplying top and bottom by 2 is going to give me 12 times the square root of 7. For this fraction, multiply top and bottom by 5 minus 100 times the square root of 7. And for this fraction, multiply top and bottom by 10, so plus 80 times the square root of 7. 12 plus 80 is 92, minus 100 is negative 8. And that's exactly the right answer. Do notice that the fraction reduces by 2, so we're going to get negative 4 times the square root of 7 over 10. Can that be the right answer? Oh, I'm doing this better. 4 times the square root of 7 over 5. Reduce both top and bottom by 2. The radical does not get involved in the reduction. One thing that might have even made it easier, if I'd noticed right here that those were both even, that would have also worked to make a common denominator 5 instead of 10, but again, if you don't notice it there, you'll get it here. Number 13. I'm going to use elimination. I've got 2x and 2x, so I'm just going to change the signs on the top equation. So minus 2x plus 3y equals negative 1. Change 1, change all. If I combine like terms, negative 2x and positive 2x cancel. 3y plus y is 4y. Negative 1 plus 5 is 4. So y equals 1. Then I'm going to go back to this equation. 2x plus y equals 5. Since y equals 1, I'm changing that y to a 1. Move the 1 over. 2x equals 4. Divide, we get x equals 2. So 2, 1. Guessing it'll be a lot like that on the test. So solve by factoring. If I'm going to solve by factoring, I want to first of all get it equal to 0. So I'm going to move the 7x squared over to the left. x cubed minus 7x squared plus 12x equals 0. Okay, it's going to be a cubic function on the test, so a common factor of x is there. Take x out, I got x squared minus 7x plus 12 left over. If x squared minus 7x plus 12 equals 0, then I get to x times x minus 3 times x minus 4 equals 0. The factors of 12 that multiply to make 12 and add to make negative 7 are negative 3 and negative 4. Once you get factor form equal to 0, then to get the answers, we take factor 1 and factor 2 and factor 3 and say each one of those individual factors equal to 0. We got it down to a product. If x equals 0, I'm multiplying 0 times everything else, I get 0. If x minus 3 equals 0, I got 0 times everything else equals 0. If x minus 4 equals 0, 0 times everything else equals 0. So x is equal to 0. Negative or positive 3 minus 3, so x equals positive 3 to make 0. And 4 minus 4 equals 0, x equals positive 4 to make 0. So 0, 3, and 4 will be the right answers to that one. A lot of you are leaving it in factored form but not getting the answer. So again, if it says solve, we're looking for x equals numbers for your final answer. Number 15, find the equation of the line that has a slope of 3/4 passes to the point 12, negative 3. Nothing weird about this. They tell you the slope, they tell you the point. They're simply asking you to find the y equals mx plus b structure. Slope is 3/4, that's the m part, and b is what we don't know. We're going to use that exact slope with this exact point into that equation to find out what b equals. So y is negative 3, m is 3/4, x is 12, and b is unknown. So I always suggest doing the fraction first. 12 divided by 4 is 3 times 3 is 9. If it does happen to come out to a whole number, let it come out to a whole number. Don't write 9 over 1. Don't write 36 over 4. Get me a simple whole number answer out of that if it's possible. And if it is a whole number, just leave this as an integer. If this came out as a fraction, create a common denominator over here. Move the, I'm ahead of myself here. Move the 9 over as a negative 9. And negative 3 and negative 9 make negative 12. So my slope is 3/4, my y-intercept is 12, so my equation is y is equal to 3/4 x minus 12. Please make sure the x looks like it's to the right or above the line. Do not make it look like it's below the line. That does create a different type of graph. So make sure that x is written properly over there in your final answer.